Welcome to Math 210. Today we're going to be talking about indirect proofs. Up until this point, you have been doing proofs that begin with a true statement, which you may know as the given, and through a series of statements and reasons, you prove another true statement. At this point, though, it is helpful to know how to prove indirectly. This type of proof starts with a false statement, and through a series of steps leads to another false statement. This first false statement is otherwise known as an assumption that contradicts what you are trying to prove. The second false statement contradicts the given or a known theorem. This will become clearer as we explain how to prove indirectly. In order to explain this, we are going to use an example of an indirect proof. To start, we need to create a false statement. In order to do this, you must assume the opposite of what you are trying to prove. In a normal proof, you assume that the statement you are trying to prove is true. However, in an indirect proof, you are contradicting that true statement and making it false. In this case, what you're trying to prove is that line BC does not bisect angle ABD. In order to prove this indirectly, you must make the assumption that BC does in fact bisect ABD. And you would write it out like this. From here on, prove like a normal proof until the statement contradicts the given. In this case, either prove that BA does not equal BD or CA does equal CD. So let's go through the proof. First, we have the assumption that BC does in fact bisect ABD, as we stated earlier. Next, we know that what we have deemed as angle 1 and angle 2 are congruent because of the definition of an angle bisector. That gets us an angle for congruent triangles. Next, we use the given statement of BA equals BD in order to get another side. Lastly, we prove that BC equals BC using reflexive property to get our last side. Now we have two sides at an angle. We have two congruent triangles, BAC and BDC. Using congruent parts of congruent triangles are congruent, we can say that CA equals CD. However, this contradicts the given statement that CA does not equal CD. Now we have reached an important step. CA equals CD is a false statement because it contradicts the given. This goes back to when we explained that the first false statement, also known as the assumption, leads to the final false statement, or the statement that contradicts the given. Now that we know that CA equals CD contradicts the given, the next step needs to show that CA does not equal CD is our statement, and our reason is that the previous statement contradicts the given. We can now move on to our last step. The assumption is false because through a series of steps, it led us to a statement that contradicts something that we know is true, the given. If the assumption that BC bisects angle ABD is false, then the opposite of the assumption, BC does not bisect angle ABD, must be true. You will notice that the statement is also what we are trying to prove. The proof is now true. Looking back at this entire proof, it is clear that the first step is an assumption that contradicts what we are trying to prove. The second to last step explains how we have contradicted a known statement or the given in this situation, and because of this, we can say that the assumption we had at the beginning is false, and what we've been trying to prove originally is true. Now, we would like to look at a harder example of an indirect proof. See if you can follow along. And if you are feeling ambitious, pause the video and try the proof alone. First, we have the assumption that PQ equals QS, which contradicts what we are trying to prove. Next, we know that angle P equals angle PSR, and that N is the midpoint of MP, which is given. Angle 1 equals angle 2 because of the vertical angle theorem. Next, we know that triangle NPQ is congruent to triangle RSQ because of angle side angle. Then, NP equals SR because of congruent parts of congruent triangles are congruent. Then, NP equals MN because of the definition of a midpoint. And MN equals SR because of substitution. However, MN does not equal SR because it is given and the previous statement contradicts the given. We now know that PQ does not equal QS because the original assumption is false. Before we go on to the final review, there is an important theorem to learn for future proofs. This is the exterior angle inequality theorem. This states that the measure of an exterior angle of a triangle is greater than the measure of either of its remote interior angles. In this case, 110 is greater than either 50 or 60 degrees. Now, let's review the lesson. Remember that when we prove indirectly, we are starting with a false statement and ending with another false statement. The first line of the proof contradicts what you are trying to prove and is called the assumption. The third to last step is false. The second to last step contradicts the given, so the assumption you made at the beginning is false, and you've proven your proof. Remember that the ending false statement does not just have to contradict the given, it can also contradict a known theorem. Thank you for watching.